In this video I'm going to show you how to use long multiplication to multiply two-digit numbers by two-digit numbers. I'll do two examples. Here's the first one. Use long multiplication to find the answer to 67 times 42. Before I do that, I want to get an estimate of my answers so that I've got a rough idea of how large it should be. It gives me the opportunity to do a sense check at the end. So 67 is close to 70. That's the nearest multiple of 10, and 42 is close to 40, so I will do 70 times 40, 2,800. That's my estimate. As I said, when I get my final answer, I'll be able to check to see that it's close to 2,800, and therefore be reasonably satisfied that I got the correct answer. Okay, 67 and 42. I now need to put these into two columns, a column for tens and a column for the units. 67 and 42. It doesn't matter whether you put 67 on top or 67 on the bottom. In multiplication, it will always turn out to be the same answer. Okay, now that I've set those up, I would just like to mention the direction of the multiplications that we're going to do. I just want to help us all visualize exactly which ones we're going to do in which order. We'll start always with the bottom right number. And fanning out from there, from that number, we do 2 times 7 and then 2 times 6. Once we've done that, we'll move and write down to this line, write our answers here, and calculate the answer to 4 times 7 and 4 times 6. To go over that just one more time, it's very, very important to understand this order. We'll do 2 times 7 first of all, then 2 times 6. Once we've done that, we move over and do 4 times 7 and 4 times 6. Okay, let's start. 2 times 7 is 14, so I'll write the 4 there and the 1 there. That kind of looks like a 14 the way I've done it, like that. And then I'm going to do 2 times 6, which is 12, and add the 1 that I'm carrying, 13. So I'll use the first available square for 3. And because I'm not going to do any further calculations on this line, I'll also write the 1 there from 13. Time to move on to the 4. Because this 4 is actually in the tens column, that means it's worth 40. And any whole number multiplied by 40 is going to end in a 0. So I'll start that by writing a 0 there. Now I can start doing 4 times 7. That's 28, so I'll put the 8 there. Hold the 2 down there. 4 times 6 is 24. Add the 2 that I was holding, 26. There's the 6 in the first available square. And I'll write the 2 in the next available square because there are no more calculations in this row. Now that I have these two numbers, 134 and 2,680, the final step is to add them together. 4 plus 0 is 4. 3 plus 8 is 11. 1 plus 1 plus 6 is 8, and 2 plus nothing is 2. So my answer is 2,814, which is very close to my estimates. And before I go on to the second example, I'll just try and explain why this works. And this method works because what we've just done is 2 times 67, and put the answer here, and then 40 times 67 and put the answer here, and then we added the two numbers, our two answers together, and that gives us the answer to 42 times 67. So it might seem like a crazy method and we're not sure why this works, but hopefully this is a demonstration or an explanation as to why this method of long multiplication is getting us the correct answer. Okay, use long multiplication to find the answer to 53 times 96. Starting with an estimate, I would round 53 to 50 and 96 to 100 and then multiply those. That's 5,000. So 5,000 is my estimate. Okay, now I need to set up two columns. Again, 1 for tens, 1 for units, 53 times 96. As I mentioned before, it doesn't matter whether you put the larger number on the top or on the bottom, the answer will still come out correctly, assuming everything else has been done in the right way. Another opportunity to talk about the order in which we're going to do things: 6 times 3 and then 6 times 5, followed by 9 times 3 and 9 times 5. Okay. 6 times 3 is 18, put the 8 there, hold the 1 down there. 6 times 5 is 30, add the 1 that I was holding, 31. I've finished working with the 6, now I'm going to go over to the 9. But of course that isn't a 9, it's really a 90. That means that the answer here is going to end in a 0. So the first thing I'll do is write the 0, and then proceed with 9 times 3, which is 27. Write the 7 there, and hold the 2 down there. 9 times 5 is 45, plus the 2 that I'm holding here, 47. So I'll put the 7 there, and the 4 there. And now it's time to add. 8 plus 0 is 8, 1 plus 7 is 8, 3 plus 7 is 10, and 1 plus 4 is 5. 5,088 is pretty close to my estimate of 5,000, so I'm satisfied that I've got the correct answer. Of course I may have made a mistake, and the only way to really check is to do a division and check that you get back to one of these factors. A word about carrying and holding numbers in certain places. The reason why I choose to write 1 here, this is the 18 from 6 times 3. The reason why I choose to write the 1 here and not up here, as some people do, is that when it comes to working on this line, it can sometimes cause confusion with numbers that I've been carrying up there from this line. I'm no longer certain whether the one that I was carrying here really has been dealt with, or whether I need to include it in this new line. So I would rather write it here, which makes it look like 18, and that way I know for sure that it's to do with this line of calculations. The second thing to mention is that be careful with numbers that you've held here when it comes to adding. So this 2 was sitting here, that 2 was sitting there because it belonged with the 7 here to make 27. And we got that from when we did 9 times 3. But what I needed to be very careful of was when I was adding, that I didn't include it. So I did 8 plus 0 is 8, 1 plus 7 is 8, 3 plus 7, I ignored the 2 because I knew that that wasn't relevant to the addition. I ignored it, so I did 3 plus 7 to get 10. And there's the 0. And then adding, I carried the 1 up there. 1 plus 4, 5. Okay, that's the end of this video. In the next video, I'm going to show you how to multiply a 3-digit number by a 2-digit number using long multiplication.